So my original plan was to do little filler lessons along the way, and it hasn't worked out. But today I managed to think that we should squeeze one in. So I'm gonna do a filler lesson today. These are little lessons that, they're not a huge deal, but they're nice to know. So I thought we did, and also you're going to see this question come up in our next section in that book. It'll help you kind of understand how to answer those. So, go ahead. I would keep it, and if I were you, I would probably put it under, let me get back to you on that, what section would be good for it. In terms of relevance, it should probably go in a certain section. I don't, just, it's, yeah, it's called mini lesson, that's fine. All right, so first of all, before we begin, what does it mean to say that one quantity is proportional to another quantity? So, let me calibrate my pen really quick. Proportional basically just means that something is exactly the same, it's just bigger or smaller, right? So, a map is proportional to the land it represents, so to speak. Okay. And what's the difference? What's proportional mean then, according to the geography teacher?
Proportional is a map can be proportional to, it's to scale because it's not like the same thing. But land and mass can be proportional to each other, but because map is like a model of that, it can't be proportional.
Okay, well, in general.
Sorry.
That's okay. In general just means something bigger or smaller, right? So, if I had quantity 1 and quantity 2, then they would be proportional if quantity 1 is like, for instance, k times bigger than quantity 2. Okay? So that's what's meant by proportional. Okay? So I want you guys to take a moment here and go ahead and figure out the derivative of that function, please. All right, guys, so what's our answer here? Y prime equals what? Do you guys see how those answers are proportional to each other then? Okay. So this is kind of one of our big conceptual takeaways for today. I'm going to show you guys a lot of process, and most of that process is really just algebra math, no calculus really at all. The big concept takeaway is that e functions, exponential functions with a base of e, they're always proportional to their derivative. Okay? Now that's important because there's a couple of problems where that comes up. So let's go ahead and find this. We'll work through this together really quick. I was reading a word problem one time, and it was coming from one of the Barron book, actually. And I hadn't covered this concept with my students, and so I'm going to show you guys how I solved it. Okay, and the reason for that is because that's how technically the calculus is involved. But after I show you how I solved it, I'm going to show you that you really don't need to do all that, and you can just use some algebra to get the answer. Okay, so I was reading a problem, and here's what I read. I read a sentence that went something like this. It said, the rate of change of a function is proportional to the function itself. Okay, so what I saw in my brain then was I saw that dy dx, the rate of change of a function, right, dy dx, is proportional to the function. Now luckily I remembered that meant that whatever the function is, it's just k times more than the derivative itself. Okay, so we have two quantities that are the same if you just multiply one by a certain constant. Does that make sense? So that's what I wrote. And then their question was essentially, so what's the function, right? So I need to find out what y is. Well, when you have a derivative, how do you find the original function? We integrate it, right? But the problem here is that this is an implicit differential equation. The y is in there too, right? So when you have an implicit differential equation, you want to integrate. What do you have to do first? No, No, you don't want to get y by itself. It's close though, but not quite.
Yeah.
Yeah. So it's called separating the variables. You want all the x's on one side and all the y's on the other. So what I'm going to do then is I'm going to divide both sides by y. And then I'm going to multiply both sides by dx. And that gets me here. You guys good? So now I've got all the y's on one side, x's on the other. And now we can go ahead and integrate, right? Okay, so what's the integral of 1 over y? I think that's what you said, right?
Yeah.
Okay. And now, it is ln y, but anybody remember a little detail?
Plus C.
Well, yeah, not yet. Do you remember you have to do that? Yeah, when you integrate, you always have to put in. It's easy to forget. I've actually seen that be relevant and necessary a few times. Anyway, here, this is just a constant, so I'm going to take it out for now. Now, what is the integral of just dx? What would that be? Huh? It's just going to be x. And I'm going to put my plus c over here. You don't need a plus c on both sides. The reason you don't need a plus c on both sides is because you could technically combine them and just get a new c, right? So we'll just put it on one side and get that. So there's that. Now, I'm going to get the y by itself. So if I wanted to get y by itself, what would I need to do? Yeah, put an e on it. The math word for that is exponentiate. So we want to exponentiate both sides. Put an e there. Yeah, I know what you mean. You're good. So I'm going to exponentiate both sides with an e. And then it's kind of like these cancel, right? And I'm left with this. Oops. Yeah, I guess right. Okay. Well, I think it's really obvious what it says. It says yekix. All right. Yekix. All right. So, I try to keep the jokes to a minimum in your class. You guys are kind of crazy. All right. There you go. Before I go on to the next step, I wanna ask you. Don't write this. Just watch. If I had x to the third times x to the fifth, what would I have? Because you add them, right?
Yeah.
So now you guys are used to going this way, right? But could we work backwards? Okay. So that's what I'm gonna do here. Why would I do this? Because that's how the answer is usually written. So I'm going to take this plus c off and write it as a separate e to the c. Why? Because that's how they usually do it. And so I want you to be used to that. It is weird. Now, it does, but they go one step further. This is just a constant, right? And this is just a constant. So it's just a constant. So what I'm going to do then is this c is not going to be the same thing as my new c, but I'm just going to make this whole thing one big c. I'm going to put a little 1 there so I know it's not the same c as the original c. Does that make sense?
C.
All right, so I'm going to put c1 there. There's that. And now, since that's an absolute value, then I guess you could put plus or minus, right? No, it's a 1. That's a 1. All right.
There's no numbers.
Yeah, they're all there.
Nope. There's one right there.
Ah,
But that's
one.
not like a value, you're just denoting the
Oh, great. He has no value?
How dare you?
You know
You
what?
just,
That's all
like,
right,
you
buddy.
could
Show him where
literally
she has no
do that,
value.
like-
It's all right.
But like our number is obsolete. You
I
can
know
use
what
that
you mean.
in
It's just a representation. Joanna liked me having a seizure class. All right. So anyway, here we go. Now that's what I did. When I saw the word problem that said the rate of change of a function is proportional to the function, what's the function? I did all this work and it was all calculus and I got there. I got the right answer. Okay? But you don't have to do all that work because there's only one function that does that. It's this guy. We just saw it on the last page, right? The rate of change of a function is proportional to itself. What kind of function does that? An E function does that, correct? And we proved that on the last slide by just looking at a really simple example, right? This guy, where'd it go? Right? So here's what I want you guys to do from now on. When you guys see that phrase, which you may or may not on the test, you're definitely going to see it in that orange book a little bit later. But when you guys see that phrase, the rate of change of something is proportional to the function itself, for its growth rate is proportional to the amount there. I want you guys to have that in your brain. So it's a good little flashcard to make. So you guys don't have to do all that work. You can just know, oh, they're talking about that function, because that's the only function that does that. That's what makes E so special, actually. That's why E works so well in calculus. It's a really neat function. No matter what point you pick along the E function, the slope is always proportional to the function itself. That's really interesting. Has a really interesting property. Anyway, let's take a look at the anatomy of this function. This represents the final amount, the output. All right. This represents the initial amount. Now I'll explain why the C represents the initial amount, okay? At the initial time, what's the time value?
C.
At the beginning, what's time equal? Of any story problem, like
0.
yeah, okay, so 0. So T is 0, right? If I say T is 0, then I'm going to find my starting amount. What's K times 0?
0.
And what's E to the 0?
1.
So it's the final amount is C at the beginning. Does that make sense? So the final amount or the starting amount is C. So when you plug in 0, you get C. So therefore, the starting amount is C.
Oh,
Now,
okay.
I worded that a little bit better. All right. This is time, obviously, right? This K has a name. That K that's just hanging out there, that's what's known as the growth rate. On almost every problem that you're going to see with these types of problems, they make you figure K out first. Now, they won't tell you to do that, but you have to figure K out before you can do anything else. So here's how the word problems work with these things. They're going to give you some numbers to plug in, and your job is going to be to find out what's your growth rate first, and after you know that, then you can actually start answering the questions they want. So that's what we're going to be working on today. So let's do a teacher example here. Teacher example. Whoops. All right. Now look at the words up here. The rate is proportional to the original amount, right? That right there, when you guys see that phrase, I want you guys to think of this. Save you a little bit of time. So we don't have to do what Mr. Bailey did and start with dy dx equals ky. That would take too long. So we can just know that now. It's that function. All right. So they're telling us that the population increases by 50% after 10 years. Then after that, they ask us some questions. Now, the reason they tell us this is because this is kind of like your initial condition that you're going to use to figure out what the K is. Okay, so the first thing we have to do is figure out what K is. All right. Now, did they tell me a starting amount? No. But I'm going to pick a starting amount. So let's just say we had 100 people to begin with. Okay? So I've got 100 people. I don't know what K is, but I do know it's been how many years? 10. And after 10 years, my population has increased by 50%. So if I started with 100, how many do I have now? 150. Now you can do this. You can pick any number you want to for your starting amount just so you can find your K. Okay? All right, so let's do that. Anybody got a calculator? Divide first. How do we do this? ln, good. And what does this side become? All right, those are going to go away. And so we're left with ln of 1.5 is equal to 10k. Divide both sides by 10, and you get your final amount there for k, which is 0.041. If I'm not right, let me know. I'm just remembering it from last block. Now, what percent would that be, you guys? If I want to change this to a percent, good. So that's a 4.1% growth rate, just so you know. Now that is not answering question 1, okay? That's just finding the k. You have to do that before you can begin. Some problems, they'll just give you the k up front. They'll say the growth rate is, okay? But I'm kind of giving you the scenario where you have to figure it out on your own first, okay? You're right. Well, I'm going to show you what to do about that. It's a good point. Can I erase? Yeah. All right. So let's go ahead and take a look at the question. Question saying, what will the population be after 15 years? So I don't know what my starting amount is. I don't know what my initial amount is. But now I do know that what my k is. My k is 0.041. And the time is what? 15. Now, why can't I just put 100 here again? Well, I did that last time so I could figure out the k. That would work for any number you want to pick. But here they actually want to know what's the population, so you can't just make a number up at that point. Okay. All right, so let's do this. Can someone tell me what 0.041 times 15 is, please? Pretty please. 0.615? All right. And what is e to the power of 0.615? Is it 1.85? That's what we got last block. Okay. So here's what this answer means. Do I know my starting amount? No, it's c. But what's my final amount? It's 1.8 times greater than that. Does that make sense? So whatever your starting amount was, the final amount is 1.85 times greater than the initial amount. So I'm going to interpret this for you. 1.85 times the initial. That's one way it could be said. Or you could say it is 85% greater. So the 1 just represents the, huh? Well, you could say the population is 185% of the initial. You could say that. Or you could just say it's 85% more, right? So the population increased by 85%. It used to be 100%, right? But it went up to 185%. So it increased by 85%. So there's that. All right. How long will it take the population to triple? Why don't you guys see if you could set up that equation? Just set it up. You don't have to solve it. You can probably, but I'm not going to give you time to solve it just yet. I just want you guys to set it up. All right, if you and Noah are on the same team or something like that? Yeah. Okay. All right, so what do we get, guys? How do I write this setup? Anyone?
Y equals CE to AQ.
No. No. Sorry, I don't know how to say no in a nice way. I hope that doesn't seem rude. I just don't. Okay, good. Go ahead. 3C equals what? That is correct. So, what's my starting amount? C. The final amount is 3 times greater. Our K is still 0.041, and now we need to find T. Yeah, it's a little weird, but there it is. All right, so I'll go ahead and finish solving this at this point. I would divide both sides by C. Do you guys see why that doesn't, the C doesn't really matter when you're looking at, it just kind of cancels out. Ah, that joke's been said quite a bit today. How do I solve this? Not that you're unoriginal, I appreciate a good one. We ln both sides. No, Mr. Bailey. No, Mr. Bailey. These cancel, and I'm left with ln of 3 divided by 0.04. Well, I'm getting ahead of myself again. Where'd it go? It's really sad. Okay, ln of 3 equals 0.041t, and then you just divide both sides. And I believe we ended up with something like 26 years last block. Now why?
Years.
That answer makes sense, right? Because it took 10 years for it to increase by 50%. So if it's going to triple, I would expect it would take a lot longer than 10 years, right?
Yeah.
So that makes sense. It's good.
So it's like about 26.795.
26 point.
795.
Oh, is it 795?
Yeah, I said like 27 as in like 26 to 27 years.
Oh, I got you. Got you. Okay, so there's that. I wanted to do student practices with these. But I think I would rather let you guys work on your book after having exposed this to you, and you'll see an example like this in the orange books a little bit later. So I think I'll forego the student practice and let you guys use the rest of the blocks for your books. We only have about 15-20 minutes left, so. And then I am going to make this section that we're currently working on due at the end of class tomorrow. So if you feel like you're not making good pace, you can take a little home with you. Did you cheat?
Only a little.
All right.
Nah,